Hey guys, what's the crack? So what we're doing now is SI base units, okay? So this is something new in physics and you need to make sure that you've learned them off. There's 7 you need to know, however you only ever use 6 of them, okay? So the SI base units, what they are, is mass is always measured in kilograms, okay? So remember you're in physics, that's why it's always kilograms, okay? Mass is always in kilograms. Anything else you need to know about is time is always measured in seconds, length or distance is always measured in meters. Temperature, you've always been used to saying degrees Celsius before. Think about Pacific heat capacity. You said Pacific heat capacity was the energy required to raise 1 kilogram of substance by 1 degree Celsius. That's not anymore. You have to say it's 1 Kelvin, okay? So you need to use K and just write what that means because that's going to be new. That's our Kelvin scale, okay? If you want to know about Kelvin, we use Kelvin because 0 Kelvin is called absolute zero. So that means it's the coldest that anything can ever be, 0 Kelvin. 0 Kelvin is the coldest anything can be, and that equates to negative 273 degrees Celsius. Technically, it's 273 point and a few numbers, but as long as you know negative 273, you'll get the marks in your test, okay? So if I want to go from degrees Celsius into Kelvin, what we do is you clearly have to add 273. Now I go from Kelvin into degrees Celsius, what we do is we take away 273. Okay, so we've got mass, time, length, temperature. The other one is current. Current we know is measured in amps. Okay, that's what we use our ammeter for. So 1, 2, 3, 4, 5, 6, 7, so 2 more. The next one is amount of substance. An amount of substance we measure in moles. Okay, so a lot of people think, oh, you're never going to see moles in physics. You do, okay? Especially when you start doing the topic at the end of year 12 is when you probably started, but it is a paper 2 topic in AQA. We start doing about thermal physics. You do need to know about moles, okay? The other one then is called luminosity, or luminous intensity, that we measure in candelas, okay? But that one is the one that never gets used, okay? But these will all get used in physics. These will get used most. This only comes up when you talk about moles. So again, it might come up in your thermal physics, and it also comes up in the topic of nuclear physics. Okay, so why are they important? What might come up in your test? So what might come in test is that you might have an equation for force. And the question might say, write the units of force in terms of its SI base units. So we know force is always measured in newtons, right? That's the common unit we use for it because of Sir Isaac Newton. But that's not an SI base unit. So I had to think, how can I write a force that's newtons in terms of its SI base units? So that's when you need to start remembering some equations from your GCSE. You were told at GCSEs, you didn't, well, a lot of you, depends on what year you did your GCSEs, didn't have to learn them, right? Because you got that big data sheet. I'd highly recommend there's equations that you need to know. So the ones that you need to know to be successful at physics and just need to know off your head is work done is equal to force times distance, a really common one. Knowing that work is always measured in joules. Another one you need to know kinetic energy is 1/2 of mv squared. Highly recommend you know power is equal to energy divided by time. Highly recommend you know Q equals IT. Charge is current times time. And I would highly recommend you know E equals VQ. Energy is equal to the potential difference times by the charge. F equals ma. Resultant force is equal to the mass times by acceleration. Acceleration is equal to change in velocity over time. If you don't know those base ones, physics is going to be really hard because you need to have some knowledge in your head that when you look at an exam question, you can quickly think about things you know and then see how is it going to apply to that question. If you need to go to the front of your paper and scan for all these equations, it's going to take forever because in physics, the equation sheet is much longer in year 12 and year 13 and you don't have time to waste to look for equations that aren't important, okay? So force measured in newtons, so I'm thinking, how can I write a newton better? And I'd think about this equation, F equals ma. So I'd write, I know a force is equal to a mass times acceleration. So I know that a newton is equal to a mass. Mass is always measured in kilograms times by acceleration, and acceleration is meters per second squared. But remember, we can't leave it like this anymore because you have to write it in its indice form. So remember, from our mathematics lessons, 1 over x is equal to x to the minus 1. 1 over x squared is equal to x to the negative 2. So what this really becomes is a newton in terms of the SI base units is kilograms ms to the negative 2. This is fine because kilogram is an SI base unit, so is meters, and so is seconds. Let's say you had another one. Let's say you want to write, what would be a common one? Let's say you want to write what a watt is. So you want to write the term for power. I want to know what a watt is, okay? So what I could do is power is equal to energy divided by time. So that's my unit for power. And I know it's equal to an energy divided by time. So I need to know what an energy is. I know an energy I can write down as work done. It's a work done, which is a force times by a distance over by a time. Okay? I know forces are measured in newtons. Newton is not an SI base unit. So that's when I would say, how I can write work done is a force, which is a mass, times by acceleration. We're then multiplying that by a distance to get it into an energy. And then we're dividing by our time. And now I can write that in my SI base units. So my work done is my mass, which is measured in kilograms. My acceleration was meters per second squared. We're multiplying by another meter. And we're dividing by time, which is seconds. So when we have indices, when you multiply them, the rule is you add them. So meters to the power 1 plus meters to the power 1 gives me meters squared. So what is a kilogram meters squared. I have s to the minus 2 divided by s to the power of 1. We divide them to subtract them. So negative 2 minus 1 gives me negative 3. So s to the negative 3. Okay. So if you found the video useful, just remember to check out our lessons at the myadspace.co.uk website.